Welcome all back to some Algebra 3-ness right here. Today we're talking about piecewise functions. Now, let's kind of go through a couple smaller things about them, things before we get to the actual piecewise. Now, let's talk about graphs. Graphs increasing, decreasing, constant. Sometimes we're able to just look at a graph and kind of tell what's happening, what's going on. So as we look at this, let's talk about, start with increasing. We're going to do that in blue. Things are increasing. So it's pretty obvious. Anything going up is increasing. So this is an increase thing. And then even this, even though it's curving, it's still going up. As the value of x goes up, so does the value of y. That goes up. Let's look at decreasing variables. So decreases is going down. So once it hit this up, it started going down. But not only did it go down here, it kept going all the way till it got to this point. And then it went from here down. And let's look at constant. Constant means it's constantly the same value of y. That means it stays straight. So this is what happens on the graph. So, but let's see what happens. So let's talk about other things. The value of x the entire time is increasing. As you're moving from left to right, the value of x is getting bigger and bigger and bigger. We started with -4 and we ended up with 3 and so on and so forth. It's the value of y that's effective. That is what we're really graphing, are the value of x and y is what we're putting together. And that's what's changing. So y is going up, and it's going down, and it goes up, and it goes down, and it stays constant. But the value of x is always the same, kind of like time. Time keeps going, and we have our ups and downs, and backups and downs, and sometimes things are kind of stagnant, but life is still going. So a little life lesson in piecewise functions as well. But let's look at relative minimum and relative maximum. So relative minimums and relative maximums are just that. They're kind of like a relative to minimum and maximum. It's just the fact that there's no absolute minimum and there's no absolute maximum, because these functions are forever going to the negative infinity and forever going to a positive infinity. So there's no way to get an absolute min and an absolute max. So we look at their relative minimums and relative maximums. That means within a certain region, for example, here we're bounding our region from here to here. Let's kind of give these some more numbers. So that's 0, 1, 2, 3, 4, 5, 6. And then we got 0, 1, 2, so on and so forth. So bound between -2 and positive 1, 2, 3, 4, 5, 6-ish, 7-ish. There's these little turns. These turns are defined as relative minimums or relative maximums. Our maximum will be our highest points at different spots. So this is a high point. High points, also known as the top of the hills, are hills. We look for our hills in our graph. So our hills will be here. This is the top of the hill, so this is a relative maximum. And this is the top of this little hill, and this is a relative maximum. But let's look at minimums. Minimum goes either way. So if maximums are high points, minimums will be low points. Low points. Those are our valleys, the bottom of our valleys. So here we look at our bottom, the very bottom of our valleys. This is a relative minimum. And then also down here, that's our relative minimums right there. So that's maximums and minimums. All right. Now let's look at our piecewise functions. So this is our piecewise function. People think, oh, this is crazy confusing, and there's usually a little bracket here, but wasn't able to copy very well on here. But piecewise functions are just saying, like, during a certain part in our functions, only certain things are true. Okay, it's all based off our x and our y. So for any value of x that's smaller than -2, this is the function we use to find the value of y. For any function that is between -2 and 3 here, this is the value that you will get for y. And then for any function greater than 3, this is the function we use to find for the value of y. So all these represents different x coordinates on a graph or on our equation here. We're looking for the y coordinates using either these constants or these equations right here. So let's start with f of x. So f of x is saying when x is -5, which is less than 2, that means we put in a -5 right there. So -5 in for x plus 1. We end up getting a negative 4. F of 3, negative 3. Negative 3 still is bound right here. It's less than negative 2. So that means we substitute that negative 3 in for the x in the equation. So it'll be x plus 1. So it gives us negative 2. F of 0. F of 0 is bound between negative 2 and 3. So that means its y-axis is the constant 5. It just tells you already. When x is between negative 2 and 3, it is just 5, period. So 0 is between that, you get 5. Same thing with f of 3. F of 3 is technically still bound here because x is less than or equal to 3. So since it equals 3, then we get a value of 5. But f of 4, that's a greater than 3, so we put it in this function. 4 squared gives us 16. So then f of 10, again, greater than that, so be 10 squared or 100. Now we won't graph this because it's not constant enough, but let's look at that. So part of the homework is you're going to just have to determine what your value of your x is. You're either f of x, you have 3 different piecewise, f of x, g of x, and h of x. And all 3 of them will have individual functions with conditional values of x. They have to follow certain conditions. So find what the value of your x, what condition it falls under, and then do either that equation or that constant. But let's look at the other part of the homework. The homework, you're going to be asked to graph some of these. You're going to be graphing this. So they give you just a piecewise. Okay, either you might have 3 or might have 2. So here, our piecewise going from negative 2 to 3. So we're going to start with negative 3. So f of negative 3. 1 below, 1 at that function, f of negative 2, f of negative 1, 0, 1, 2, 3, and we'll go 1 over 4. Now 4. Now this is important, as we'll talk in a bit as we go through it. All right, so f of negative 3 is bound still is less than or equal to negative 2. So that means the value of that function is 4. Negative 2 is less than or equal to negative 2. So our function is still 4. Here's where things get a little tricky sometimes. And this is where we had a little confusion in class today. Graphically, where this ends, because where this ends and where this starts are relatively the same number, then we kind of assume it to exist right here to an extent, as we'll see here in a bit. So we're going to run another one right here. I'm going to do that in blue so you know it's not an exact, but we're going to call it, these are going to be our open circle parts, our starting point for open circle. So f of negative 2, we're going to run it in this function right here. So that's 5 times negative 2 plus 1. That gives us negative 9. So we'll keep that to the side. We have to do that because where it starts and where it ends almost are 2 different equations, and we'll see why here in a bit. But let's go ahead and continue getting our coordinates. So negative 1 is bounding between these 2, so we'll do 5 times negative 1 plus 1. That gives us negative 4. 0 is bound in there, so 5 times 0 plus 1 gives us 1. 1 is bounded between there, so 5 times 1 plus 1 gives us 6. 2 is bounded between there, so 5 times 2 plus 1 gives us 11. F of 3 goes on to the next one. 3 is greater than or equal to negative 3. So it falls in this equation, which just gives us negative. Substitute that in, so it'll be negative 3. Same thing right here, 4 be negative x, which gives us negative 4. Now, just like before, where this ends, this begins. So we have to include one up here for this function. So we're going to put it right here. So f of negative or positive 3, 5 times 3 plus 1 gives us 11 or 16. Sorry, so 16. All right, so let's start with our coordinates here. Our ones are exact answers. So we got 4 for when x is negative 3, 1, 2, 3, y is 4, 1, 2, 3, 4. Okay, there. When x is negative 2, 1, 2, y is 4 right there. And we're going to skip the blue one for now. We're going to move on. We're going to say, all right, so when f of x is -1, y is -4. -1, -4, 1, 2, 3, 4. Where we go? When it's 0, it's at 1. When it's 2, it's at 11. No, when it's 1, it's at 6. X is 1, y is 6. 1, 2, 3, 4, 5, 6. When x is 2, y is 11. So 2, 11. When x is 3, y is -3. So 1, 2, 3. 1, 2, 3. And then 4. Down here, over 4, down 4. All right. So here's where the blue ones come into play. So when you think about this, the value of, for example, -1.9999 is technically less than -2. So it's approaching, it's still bound in here. So we have to kind of include those values. By doing so, we do what's called an open circle at that spot. That's why when x is -2, is in this one, yeah, x -2, oh, over here. The wrong one. Ooh, come on, switch back. There you go. When x is -2, the value of y we're saying is roughly a 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. We do an open circle because technically the value of -2 is 4. When f of x is -2, it's 4. But we got to think about all the numbers past that. So this number is technically in here. So we have to run it in here. So, but it's not accounted right here. We are not accounting those values over here in here. So we have to include it as it starts at -2, but it does not include -2. And same thing right here. The value of, let's say the number 2.9999, 2.99999, that is still bound under less than 3. So we should run it right here. But if we have it here as 1, 2, 3, 3 goes straight down. So it doesn't, from the distance between 1 and 2, this little space right here, it's not going down. The value of y is not going down as it's approaching 3. No, it's going up until it gets to 3, which should be up here at 16, and then drops because the actual value of 3 is -3. So as we start making these piecewise functions, we have our connection that goes from here to here. And then it starts right here with an open circle and then heads this way as is heading towards 3. But then when it gets to actual 3, it drops back down to here. And then this continues this way. And now you can continue this way because it says for any number greater than, and it goes forever that way. So that's why at no point is this still a function? Yes, because you do a vertical line at those intersections. The answer, the value of 3 is not that. It's this down here because this is where a closed circle is at. The value of -2 at x, at -2 is up here, but after -2, it's down here and it's going up. So that's where we kind of had a little struggle. We at these specific spots, they have to still exist. It's where one ends, the other one has a start. But all those numbers right before that and right after that are still bound within these regions, either this region or this region. That's why we started down here. 2 is right here. The value of f of 2 is up here. But the decimal right after that, -1.99, is down here. So we can start it, quote unquote, at -9 for f of 2, but then it goes up that. So open circle means it does not include that exact same spot, but it can go up to that spot, but not including that spot. All right, so hopefully that kind of clears some confusion that we had on graphing these piecewise functions. So as your homework, on your homework, always do at least 2 less than your lowest and then 2 more than. I think we only went 1, so we can go 1 more. 5, 5 should be right there. F of 5 equals -5. So this is going down, and that goes down forever that way. And technically this goes forever this way, infinitely that way. All right, hopefully that helps you guys out on the homework. Let me know. Have a wonderful evening.